Welcome, everyone. So, today I want to talk about the recent headlines that have been going around saying that mathematicians have proved that we are not in a simulation. And I'm going to talk about this at a fairly high level today. We're not going to get into some of the mathematical details, although I may end up writing a paper on this at some point soon. Now, the reason I felt compelled to talk about this is because what we're seeing here is one of these viral science by headline types of moments where the headline doesn't necessarily reflect the underlying reality of what's, say, in the paper. Now, if the headlines had said, certain mathematicians or certain physicists claim that they've proved we don't live in a simulation, well, that would be, I think, a more appropriate headline because now that the paper has been out there for a couple of weeks, we're already starting to see objections from a number of different directions. And I'll be talking about, a few of those as we go here today. First of all, let's start by saying that this happens every few years. It's just that the papers don't always get as much news coverage as this recent one has gotten. And so every few years, you have a group of physicists or perhaps even, other scientists saying, well, we've proved that we can't be in a simulation. Usually it's because of materialistic constraints. They'll say there aren't enough atoms in the universe for a computer to be able to compute things, or it would take too much resources for a computer to be able to compute the universe. And usually those objections don't hold for pretty much some of the same reasons why this particular paper's objections won't hold as well. The last time this happened, there was an article saying that there were certain quantum events that couldn't be simulated, but the article ended with, well, we don't really know what type of computer system the simulators might have, so perhaps we're wrong. And so sometimes it's good to have a little bit of epistemic humility, I think, when we're trying to make general statements about the universe, particularly if we claim to prove something isn't possible. For example, suppose in the year 1750, the scientists said, well, we've proved it's not possible that there could be any rocks falling from the sky. Why? Well, because possible is usually a function of how much we know at the time. And if you look at human history and you look at science and our understanding of nature, not even from a few hundred years or a few thousand years, but if you spread it out to, say, the next 10,000 years, what we know today is for sure going to be described as incomplete in the best case, and possibly just completely wrong in the worst case. And so when we make statements based upon our current knowledge of things, of what isn't possible, we have to have that humility, which is often missing, I think, in the media. And again, the reason that I'm talking about this and making a video about this is because the media frenzy has sparked the group of what I like to call science trolls, right? They're the guys who are like, oh, I told you, it couldn't be true. And the headline says it's been proven, when in fact, it hasn't really been proven. As an example, physicist Sabine Hassenfelder, who doesn't even believe we're in a simulation. So she and I don't agree on that or a lot of things, but she calls this paper as being 9 out of 10 on the bullshit meter, which is pretty high on the bullshit meter. And I'll tell you why she thinks that a little bit later as we go through the different reasons, but I tend to agree. The other thing is I don't think the authors of this paper have actually read my book. Otherwise, they probably wouldn't claim that all types of simulations have been ruled out, and they would be much more modest with their claims. And perhaps the headlines wouldn't be so dramatic, which is often the case. So I've often said that the simulation hypothesis can be thought of more literally or less literally, that in fact, it's a metaphysical proposition just as much as it is a techno-scientific proposition. So let's start with the first major error I think that these guys make, and it was expressed by a gentleman named Melvin Vopson, who is a computer scientist from the UK who has been writing about information theory and how some aspects of the physical universe could be optimizations, such as gravity, such as entropy reduction, biological systems, could all be based on information theory. And so I agree with Melvin Vopson on a lot of different areas. And if any of you have read my book, you'll note that optimization is one of the key arguments that I make about why I think we're living in a simulation. Now, so Melvin Vopson and his colleague read this paper, and their response was that the authors and the paper in general makes what they call a profound category error. And that was my initial reaction when I read the articles and then when I looked at the paper. And what that means is you're applying the wrong tools for something. And part of the reason why is when we talk about being in a simulation, we would be inside the video game or the simulation, and we would be trying to prove what is happening outside. And so it would be like Mario and Luigi talking to each other and looking at, the mushrooms or the barrels, and they're deducing the laws of physics based on these mushrooms and barrels. And then they'll say, well, we certainly could not be inside a video game. We couldn't be in a computer because there just isn't enough power for this thing to happen. Or there are elements here that are coming from somewhere where we can't explain. So therefore we can't be in a simulation. To make it even more direct, suppose there was a LSL, which would be Luigi scripting language, that was available to the players inside the game. Or if you're in Microsoft Excel, you were working with, say, the macro language. And they're like, well, we couldn't use this macro language to build, the entire Microsoft Excel or the entire world of, Super Mario Brothers or Donkey Kong or whatever game it is that you're playing. And that's sort of by design that you may not be able to do that. But if you start to make conclusions about the physical world outside of the game, you're most likely going to be wrong. And so that's why I think that it is a profound category error. Now, as we step back and look at this at a high level, one of the criticisms that's been put on the simulation hypothesis in the past is that it may be non-falsifiable, right? Meaning that it may not be possible to prove that we are not in a simulation. And that's exactly what these guys claim to do. So we went from criticisms that say it can't be proved to we've proved that we aren't in a simulation. And in the paper, as I said, I don't think they read any of my works because I didn't see them quoted. Otherwise, they might have been a little humbler in their approach, particularly around quantum mechanics. We'll talk about that a little bit later as well. But they do quote David Chalmers as one of the key guys who's put out work on simulation theory. And Chalmers himself has said many times that if the simulation is perfect, then there would be no way for us to tell if we were in a simulation, and no way to tell if we were not in a simulation. It would be kind of like saying that we have mathematically proved that there is no creator, there's no God. So that gets right back to the category error. And it's a criticism that scientists often make about religion, is that there's no way to disprove or prove it. That said, turns out just because something is not falsifiable doesn't mean that you can't actually find some evidence that it might be true. And that's why I always, make the assertion that we may be in a simulation, and here's some reasons why I think so. And you have to put probabilities on it, and you can disagree on what those probabilities are, but they're almost never 100%. So again, it's kind of a category error to say that the mathematics in the universe shows that there can't be a creator from outside the universe. And oddly enough, this paper may show exactly the opposite of what they claim to show. So anyway, we'll come back to that. So in the paper itself, one of the things a couple of things that they talk about is that they use quantum gravity and string theory as their key examples to try to show that if there is an information layer to the universe, the famous it from bit phrase from physicist John Wheeler, which was updated by David Deutsch to it from qubit. They said if there was an information layer, that you have to have something more than just algorithms in order to have that be what we observe in the physical world. And so what they claim is that we would need a non-algorithmic understanding in order to make the world look as it does today. And how they get to that point is they use Gödel's incompleteness theorem. Some of you may have read Gödel-Escher-Bach, for example, and Gödel, worked with Einstein. There's a great book out about him, but his incompleteness theorem is sort of a clever argument that says you can put together some semantic statements like, this statement is not true. And if it's true, but it says it's not true, you get into these paradoxes. But in the end, what he says is that in any formal system, like mathematics, there are axioms within the system that you can't prove within the system itself. So they have to come from outside of the system. That's why these systems are incomplete. And so, what they claim is that an algorithmic computation of the universe would be incomplete. So there would need to be something from outside the simulation. So again, this is where I think they've misunderstood what it means to be in a simulation. The whole point of saying that we're in a simulation, or in my case, I say we're in kind of a video game, is that there is an outside world that is providing input into it. So, with Gödel's incompleteness theorem, you may not be able to prove certain fundamentals about the universe, and you may not even be able to disprove certain fundamentals, but you need something outside the system that's sending that information in. That, to me, shows we might actually be more likely to be in a simulation than less likely to be in a simulation. Now, what kind of examples do they give for this non-algorithmic understanding? Well, let's come to that in a minute. So I mentioned Sabine Hassenfelder. And Sabine mentioned in her little video that she made on this. And again, I find it interesting because she doesn't even believe we're in a simulation. So you think she'd be jumping up and down to say, hey, these guys proved it. But she's not saying that. She's saying that it's kind of bullshit. What she said is that they are claiming that within physics, there are certain properties that are not computable. But then she says, well, we haven't actually observed any of those properties. And the fact that we haven't observed those might mean that this paper is showing us that we could actually be in a simulation. Okay, let's bring it back to what do they mean by non-algorithmic understanding? Now, one of the examples they use is the collapse of the probability wave. And they use the example of OOR, which is Stuart Hameroff and Roger Penrose's theory of consciousness, that microtubules cause the collapse of the probability wave. And that collapse is sort of a undecidable or non-computable element to the whole thing. So once again, if they had read my book, they would realize that I'm making the argument that the collapse of the probability wave is exactly why we're in a simulation, not the opposite. It's because you have an observer, and that observer is the player of the game. And so the player of the game is providing the human cognition, which is one of the few things that they say is actually something that requires non-algorithmic understanding. And so the way the world is rendered, it's rendered for an observer, a player of the game on their computer. And when you do that, there are all kinds of things that you fix inside the game that you couldn't compute from inside the game, but those things come, from the game designers themselves. So I think, using the example of quantum mechanics as a kind of non-algorithmic understanding may undermine the whole argument that we're not in a simulation, because I have always said that I think the collapse of the probability wave is one, an optimization, but it's an optimization based on the cognition of the player who is outside of the simulation and who is participating in the simulation. So what they've done is they've left out the RPG version of the simulation hypothesis. And that is what David Chalmers, who they did quote, but again, I don't think they understood his work, calls the matrix hypothesis. And the matrix hypothesis is basically the idea, like in the Matrix, that Morpheus and Neo and Trinity exist outside of the simulation. And so they are doing this non-algorithmic thing. Where is the matrix? It's in their minds, right? So it's within whatever consciousness structure. As one observer online put it, these guys may have inadvertently proven that there, in fact, needs to be a God or a creator. So eventually they say, well, you need a meta theory of everything. And they try to define that in some mathematical terms. But basically, what you need is a metaphysical framework of something outside of the system that can bring things into the system. And so that brings us to quantum computing. And now, I've seen objections to being in a simulation in the past that, there aren't enough resources, it would take too long to compute things. But what's interesting about quantum computing is that it is actually based on the idea that quantum indeterminacy is a feature of the computational system itself. And they completely ignore quantum computing within their paper, even though they mention Deutsch and it from bit. And so that would provide a computational way to do a collapse of the probability wave based upon whoever happens to be running the program. Now, I wrote a whole book called A Simulated Multiverse, which actually gets over some of the problems that theorists have with the parallel universes theory. And just recently, Google came out and showed that their quantum computing system could solve a problem that would normally take not 100 years, not 1,000 years, like something like a septillion years. And how do they do that? Well, nobody knows, but the best guess is that they're going outside of the physical universe into these multiverses. And basically, they're computing all the possibilities at once. And then they're coming back with the answer when the measurement is done. So I think in the end, these guys need to basically read my books before they write another paper and try to think about the metaphysical implications. And I haven't even gotten into, the metaphysical implications the paranormal phenomenon, because again, these guys are coming at it from a purely rationalist point of view where they ignore data of anomalies that actually happen in the real world. There was a British chemist named William Crookes. And so I'd like to end with a quote from him. And he investigated a lot of this weird phenomenon. And he had a quote when people said, this isn't possible, these things could happen. He said, I never said it was possible. I just said it was true. And basically, what he's saying is that what's possible is a function of where our knowledge is at the time. So this is where I started this video. And where our knowledge will be in the future, maybe, light years beyond that. So trying to make assertions when we don't really know the nature of the universe may end up being completely wrong. So anyway, those are my initial impressions, and I may write up something more formal at some point about this idea. But I guess if I were to leave you with a message is, I don't think they've proven that a simulation is impossible. In fact, they may have proven it's more likely that we're in a simulation.